Please welcome to the stage Senior Researcher of Hydrogen and Fuel Cell Lab, Yoori Kim.
Thank you, Carl, and you're spot on. Ocean transformation isn't just about ships far out at sea, but really every domain of our living. And that includes how we power our world. That's why a central pillar of our ocean transformation is ocean energy, developing efficient, renewable sources of power across our oceans. Free from the usual restrictions of land energy developments, ocean energy is much more universally accessible globally, which is why we believe ocean energy presents true potential for transforming the global energy mix. Our goal is to lead this transition by building a sustainable ocean energy ecosystem from production to transport and applications. For energy production, where the critical challenge is securing stable foundations for equipment and facilities, HD Hyundai is meeting that challenge with versatile offshore platforms that will be commercially viable. Our high-float platforms can float energy production facilities anywhere, regardless of depth or topography, and maintain stability even in harsh weather thanks to its center turbine design. Cost-wise, its structure is optimized for ease of production and standardized for economies of scale, and automated production at our smart yards can reduce initial costs, while high-float's passive ballast operation minimizes maintenance costs. We will use these incredibly versatile offshore platforms with various energy production facilities to create ocean energy clusters. Offshore wind farms, for example, are much freer from restrictions than onshore wind farms. That's why offshore wind is expected to grow much faster than onshore. From generating 135 terawatt-hours, 0.5% of world energy production now, to 7% with 5,000 terawatt-hours by 2050. But the real challenge is to move further from our coasts to harness the stronger and more consistent ocean winds far out at sea. Our stable floating platforms are paving the way, like this new floating offshore wind farm being built in Korea with a planned capacity of 1.5 gigawatts. A massive leap from our largest one now at only 88 megawatts. Another exciting possibility is small modular reactors. These next-generation nuclear fission reactors are only 1/6 the size of conventional nuclear power plants, small enough to go on our ships, and more secure with enhanced safety features. And because they are deployed as prefabricated modular units, SMRs are simpler to build, more affordable, and offer greater flexibility. We believe HD Hyundai has much to offer, having already demonstrated our capabilities with ITER, the largest ever nuclear fusion reactor project. We developed vacuum vessels for containing plasma at 150 million degrees Celsius, 10 times hotter than the sun's core, a mission of truly historic significance which we are successfully delivering. So, with a proven ultra-precision engineering capability, we continue to explore the potential of SMRs as an efficient and reliable source of energy for our ships. We can also use them on our high-float platforms as part of ocean energy clusters that will turn our oceans into new spaces for sustainable energy production. Then comes the question of sending all this energy to where it's needed. Underwater cables are the simplest option, but not for long-distance transfers from one continent to another. That's why we are building the hydrogen value chain to efficiently convert and transport energy carbon-free. It starts with SOEC for water electrolysis, again, on our versatile high-flow platform that uses the renewable electricity to produce green hydrogen. Here, using the heat from the SMRs, we may even achieve 100% conversion efficiency. Then, our future energy carriers will transport this clean hydrogen efficiently and safely, connecting the most cost-competitive sources with pockets of high demands. This is how we will form a truly global ecosystem for sustainable energy. And to complete that ecosystem, we are also developing a range of applications for ocean energy, especially hydrogen energy systems for land and sea. These hydrogen charging stations will supply our lineup of carbon-free construction equipment like hydrogen-powered excavators and forklifts, as well as a fast-growing range of hydrogen cars and machines. We are also developing our first-generation solid oxide fuel cells together with the Fraunhofer Institute in Germany. SOFC does the reverse of SOEC, converting hydrogen to generate energy. Our goal is to deliver SOFC with a total efficiency of 85% by 2025. That's double the fuel efficiency of conventional fossil fuel engines. With groundbreaking efficiency improvements for both hydrogen production and power generation, we'll be able to use these fuel cells at fuel cell power plants, as well as on our ships, especially larger vessels. That'll accelerate the electrification of our fleets and deliver approximately 30% reduction in fuel costs and CO2 emissions. So, we really are drawing on every domain of Hyundai's extensive portfolio of technologies and businesses to establish this sustainable ocean energy ecosystem. Of course, we can't do it alone, which is why we are partnering with leading innovators like GE. Today, it's my pleasure to invite Jan Kjaersgaard, CEO of Offshore Wind, GE Renewable Energy, to share his perspective on ocean energy transformation. Over to you, Jan.